Hello and welcome to Stellantis Tech and AI Podcast. I am Marijana Cestaric, your special guest host for today's episode. I'm the global lead for HVAC and engine system team here at Stellantis. We have an exciting episode for you today, a topic that just about everyone loves to stress about in the world of growing electric vehicles, fuels and exhaust. Or do they? Interesting contemplation. Do people stress more about gas or electricity when it comes to vehicle propulsion? We'll let you answer that one, but for today, we dive into ever-changing world of fuel and exhaust. What type of fuel systems are out there? Where does my fuel go? How clean is the air coming out of the exhaust pipe? And my favorite, how far can you or I really go on empty? We're breaking it all down. I'm thrilled to be joined by two of my main team members on these systems, Namir Konja, Global Responsible for Fuel Systems here at Stellantis, and Lorenzo, Monaco, Global Responsible for Exhaust Systems at Stellantis. Namir, Lorenzo, hello to both of you, and thank you for being a part of today's episode. For starters, would you both please briefly share your background?
Hello, Marijana. Thank you for the invitation to be part of this podcast. So Namir Konja, Global Fuel Systems Responsible. I've been with the company 30 years. Last month, I've had different roles throughout my career. I actually started my career here at Chrysler when it was Chrysler in 1995 as a design release engineer. And I have had different roles and responsibilities throughout the year, namely fuels, exhaust, and powertrain integration responsible in a minivan platform, then vehicle development supervisor, then vehicle integration responsible, promoted to fuel systems responsible in 2014. And as the organization and FCA became global, continued as global responsible, and then with Stellantis in 2022. Prior to that, I've held different roles with three different suppliers before coming on board at Chrysler.
Very good. Thanks, Namir. Lorenzo, how about you? Tell us a little bit about your background.
Hello, everyone. Thank you, Marijana, for this opportunity. I'm Lorenzo Monaco from Italy, and I'm a mechanical engineer. I joined Fiat 23 years ago as a project chief of fuel and cooling systems for the second generation of Fiat Panda. Then I became a project responsible for many other programs for 4 systems of our department: fuel, cooling, exhaust, and intake. In 2018, I became a regional system responsible for Europe for exhaust and intake systems, managing around 25 people. When engineering became global in 2020, I held the position of global FCA responsible for intake system, managing around 50 people. Then, after the merger, when Stellantis was created, I became exhaust system global responsible for all the regions and all the vehicles, all the applications, managing around 100 people. And that is my current role.
Fantastic. I do find professional paths really intriguing, and your 30 years and 23 years in these technologies is quite amazing. But tell me a little bit more about the global organization, 2020. What does the global really mean? How is it managing global teams at Stellantis? Which regions are we talking about? Would either one of you chime in a little bit on that?
Yes, sure, Marijana. So for me, when we became global, it's really opened up my eyes to the different types of vehicles, the different types of requirements, and customer functional objectives. Vastly different. The parts, I would say, look the same, but the requirements and regions differ. For example, I'll use the evaporative emissions, and I think we'll get into this later. In North America, we have requirements for ORVR, which is onboard refueling vapor recovery. And we have to capture the hydrocarbons that are emitted to the atmosphere during a refueling event. Not the case in the other regions, such as in large Europe or South America, although South America has started phasing in this requirement after North America. So to me, this was the biggest challenge and surprise. The nice thing about the North America Fed regs were leading the way, so everything that followed in the other regions was basically following the type of technology parts that we've implemented in North America and the other regions to meet their Fed regs.
Very good. Thanks, Namir. Lorenzo, did you have anything to add on the exhaust? Is it same experience for you or different?
But for sure, exhaust is very similar fuel for regulations that, as Namir said, are very, very different region by region. So we have to customize our development according to these regulations. And in addition, when we became global, for sure, first of all, Fiat Chrysler, we had to standardize harmonize all the core documents, the specifications, and the same when we became Stellantis. So it was also another very big challenge. And today I can say that we have completed this process, but it was very, very interesting to see how the validations were managed and the standards, the specifications were defined in each companies, because originally Chrysler was a different company than Fiat, and PSA for sure was a different company than FCA. So another interesting activity and that we have managed in the past.
Very good overview. Thank you. Okay, so let's start getting into some technical questions. Let's learn a little bit more about each one of your systems. Namir, let's start with fuel system. What is really part of the fuel systems? How would you best describe it?
So, Marijana, for simple terms, I would bucket it into 4 different categories. There's the fuel filling system, which comprises of the fuel pipe, cap or capless module, and obviously coupling to the fuel tank. And then there's the fuel storage, the fuel tank, and the valving and the venting components within the fuel tank assembly, which also includes a delivery module. And then the third subsystem I will classify as the fuel delivery, which consists of the fuel delivery module and the fuel lines leading to the engine rail or high pressure pump. And then there's a vapor management system, very transparent. It's a evap canister and leak monitoring system to assure throughout the life of the vehicle we have a leak-free system. And then last but not least, sensing and controllers. So for my perimeter, we have a fuel level sensor, liquid pressure sensor, vapor pressure sensor, and fuel pump speed controller. All these components work together not only to provide the fuel flow and fuel level indication to the customer and to the powertrain group for calibration, but also for OBD diagnostics.
Very good. Thanks, Namir. Lorenzo, how about exhaust systems? What are the parts of the exhaust systems in general?
So exhaust systems is focused mainly on development of the entire exhaust line. So from the engine till the tailpipe. And the main 2 goals of the exhaust line are, first of all, to clean the exhaust gases in order to meet the regulations that we have mentioned before that are different region by region. This is done through catalyst for gasoline application, gasoline particulate filters, DPF and SCR systems for diesel applications. So it depends on the application. You need different components and systems, sometimes very complex and complicated. The second main goal is to reduce the noise coming from the engine. And this is done through mufflers, silencers, in order to meet also in this case the homologative requirements that are different per each region. In particular in Europe, they are very, very, very severe in terms of limitations. For some specific applications like SRT or Maserati, just to mention famous sports brand, another our very important goal is also to create a sport sound. And this is very, very interesting because you have to test many solutions also with top management to find the best solution that typically is really appreciated by our customers. So I can say that based on my experience, in the past, we have done a good job. So we will have to continue in this way. And lastly, we have also heat shields that are very important because we have also to protect the boundary component from the heat that is created and generated by the exhaust systems and the exhaust gases. And last part of the exhaust perimeter, quite recent, also on BEV vehicles, we need the gassing pipes, so our metallic pipes that are needed to avoid that in case of thermal runaway event, so short circuit into the battery pack, you can have hot and very dangerous gases into the cabin, for our customers. So it's another homologative requirement. And we work also to design this component. Not always they are needed, so it depends on the application, but is another recent portion of our business.
Very good, very good, very interesting. I always found it interesting, and maybe somebody in engineering had some humor that they added to naming cold and hot end being the one closest to the engine where your catalyst is, and cold end where it's further away from the engine. But it's not something that we would want to touch, right?
Absolutely, Marijana. For sure, we split the exhaust line in these two big families. Hot because they are closer to the engine or the turbocharger, for sure. You can have all 900, 1000 degrees Celsius, but also the cold end, so the remaining portion of the exhaust line in the underbody, but also the tailpipe is quite hot. So we have to pay attention in any case. So it's just an internal way to split the two sub-components, let me say, of the exhaust line.
Okay, so those engineers that are listening straight out of college, do not touch the cold end. Clear.
Absolutely.
Okay, very good. Let's dig into technology a bit deeper. You both named some parts of the system, right, where you have specific components. Namir, you named 4 or 5. Lorenzo, you named the same 4 or 5. Could you maybe pick one or two? Like, what are the most complex parts of the system? What that you would deem most complex in your development, in your experience, and why?
Okay, so if I may go, Lorenzo.
Yeah, sure.
So a couple parts I would say, for me, on the surface, seemingly a simple function such as fuel filling, what can be really difficult about pumping fuel into a car, right? We all do it, ideally completely transparent to the customer, as it should be, but there is a lot that goes behind designing, developing, validating a robust system so that the customer will not have an issue with premature shutoff or fuel spitting back on their feet or on their legs. The filling system, very complicated. We have many implications for a good performing system. Fed regs, for example, there's something called CARB angles. And CARB stands for California Air Resources Board. It's a regulatory organization. We actually have to have the pipes must meet a design to ensure proper interface to the fuel dispensing nozzle. In addition to that, there's requirements for the opening of the fuel door, the position to permit adequate access for proper refueling operation. And then there's the refueling emissions, or VR, onboard refueling vapor recovery requirements. With these requirements, our systems have become very restrictive because we've had to add valves, additional plumbing, and this makes the venting system more challenging to allow for proper filling. As we know as engineers, right, when you fill with fuel, you're dispensing some volume. That volume has to be dispensed or exhausted, I should say, in an efficient manner. So when you have these fed regs, it makes the system very, very complicated. In addition to that, we have to design our system to be robust to multiple nozzle manufacturers, not only in North America, but also in other regions in China and in large Europe. They use different nozzles, and then there's different nozzle type. You've seen some with bellows, for example, at Costco. Those are vapor recovery type nozzles, and there's non-vapor recovery nozzles. Other variables that impact proper fuel filling quality is the type of fuel pressure, nozzle maintenance actually at the gas station itself. If you have damaged nozzle tips, you could have a different spray pattern, and that could create different pressures and prematurely actuate the shutoff mechanism in the nozzle. So a lot goes behind a function. On the surface seems very simple, but it's very complicated. And all said, we run in the order north of 130 type of fill tests on a typical program.
Wow, very good. Thanks, Namir. Lorenzo, how about on your side? You named catalyst, DPFs, GPFs, sport sound, homologation for reducing the noise. Some of these requirements contradict each other. But what would you say on the exhaust side is the most challenging or interesting part of the design and development?
Exactly, Marijana. You got the point in this question, because the most difficult part of exhaust system development is to find the best trade-off to meet all the targets that, as you said, many times are in the opposite direction. Just to do an example, I mentioned before the acoustic, so that we have to meet homologative regulations requirement, We receive target from our MBH department, and we have to design the exhaust system to meet this target. But at the same time, we have also to clean the exhaust gases, first of all, and we need filters. And in this case, they are in the good direction, because filters are, let me say, good to reduce the noise. But we have on the other side the problem to guarantee the back pressure. We have a very, very important target to meet the target of the back pressure in order not to lose horsepower and torque. So if we have an exhaust system able to clean the exhaust gases in the perfect way and to reduce the noise in the perfect way, we have on the other side the problem of the back pressure. So every time we have to find the best trade-off, the best solution, sometimes accepting some deviations and finding the good trade-off with our stakeholders. Another important point to be mentioned, on hybrid vehicles, we have many packaging constraints in the underbody mainly. This means that the exhaust line has a very, very difficult way to be installed, let me say. So the routing of the pipes, the diameter of the pipes, the shape of the mufflers, and this could create an high back pressure. So this can have an impact on performances of the engine. So as I mentioned before, every time is very complicated to find the best trade-off, taking into account all the target that we receive, that we have.
Yeah,
but it's very exciting.
Yeah, very good, Lorenzo. Thank you. Good description. And it brings me to another point, right? We're in this, I would say, very dynamic industry right now between ICE transitioning into BEV and I would say everything in between, from HEV, PHEV, MHEV, reuse, many discussion, many propulsions out there. Lorenzo, how is that impacting your design and development? You mentioned one on hybrid, right, where there is less room, less real estate for overall packaging. Is there anything else that would change your technology in the exhaust systems in particular, depending on which propulsion system we select?
Yes. There is a second impact that is quite complicated, because we have to meet the target of emissions during a very precise homologative test. There is a very precise profile to be for the vehicle during the homologative test. And for sure, an hybrid vehicle, from some standpoint, is better because you have the electric motor that help and support the pure the thermal combustion engine to provide the torque and the power. So you have less emissions for this reason. But on the other side, the exhaust gases have to be very, very hot to have a very efficient catalysis. This is very, very, very important. And you can imagine when you have hybrid vehicles, you have the engine off many times. So the problem is that you have the exhaust gases that during the homologated profile and also the real life, the exhaust gases can be not enough hot to have an efficient process. So also in this case, with our calibration colleagues and engine colleagues, we work all together in order to meet the requirement. And not always is easy for all the applications that we have to face. They are all different, depending if they are full hybrid, range extended, plug-in hybrid, or pure ICE. So very different. So another big challenge.
Yeah, so for sure, a lot of system development and a lot of balancing of the requirements to making sure that everything works the way it's intended. Okay, very good. Namir, on your side, same question with changes of different propulsion systems. How does one compare to the other, or how is it impacting really the fuel system?
Yeah, so for my system, Marijana, in a conventional system, the fuel vapors inside the tank are always venting to the evaporative canister, and those vapors are eventually purged to be combusted. Engine vacuum draws the vapors into the intake manifold, where the fuel vapors are mixed with incoming air fuel and combusted in the engine. In a hybrid system, as Lorenzo mentioned, right, the goal is extended autonomy in electric mode. So the engine is running significantly less to enable longer autonomy. So what that means for me is that the evap canister cannot be purged at this time because the engine is off. As an enabler for longer EV mode, the fuel vapors have to be contained inside the fuel tank, where normally those vapors are being sent to the canister. So as not to saturate the evap canister, what we have to do at this point, we have to put a valve in the system which is normally closed and shuts off any flow of vapors from the fuel tank to the canister to prevent it from being saturated. Because if we did not have this valve and the engine is not running, the canister will become overly saturated, and then we'll have breakthrough of hydrocarbons, and then we become non-compliant. Obviously, that's an issue. So an additional enabler for us to do this, since we have to keep the vapors inside the fuel tank through normal running temperature, diurnals, the vapors are going to obviously heat up, expand, and the fuel tank pressure will become very difficult to manage in a conventional system. So to limit the amount of deflection under pressure, since the tank is not venting, we have to put some additional reinforcements in the tank, either inside or outside. There's different ways to execute that, but I would say that is the biggest challenge for us. Technology is there. Obviously, we have it in many of our plug-in hybrid applications, but that I would say those are the main 2 points that are different from a conventional system. Is this fuel tank isolation valve and a structural fuel tank to manage high pressures.
Yeah, significantly changes it for sure. Okay, so to move on, both of you have mentioned regulation. Seems a lot of regulation in both systems, which is probably what I find most similar, like extremely regulated. Would you name a couple, or maybe you single out some of them that are harder to or more challenging for you to develop for? What would those be? And in general, do you know roughly how many regulations go into the fuel systems and exhaust system? Namir, you want to go first?
Yeah, sure, Marijana. So for me, the difficult one is the vehicle level evaporative emissions. So depending on the vehicle test weight class, it could range anywhere from 300 milligrams of emissions to 600 milligrams on a truck application. To give you some perspective, I mentioned when I first started my first job here back in 1998 on the LEF 2 system for a truck application, the requirement was 2 grams of hydrocarbons for 24 hours. LEF 3 is about a quarter of that, so about 500 to 600 milligrams depending on the test weight class of the vehicle. And also, in addition to the fuel systems, for the full vehicle level emissions, it's not just fuels. I have about, I would say, 50% of the task for the compliance requirements. The other subsystems combined, for example, AC system, tires, body and white sealing, interior seats, carpeting, and other components also emit hydrocarbons. And the total of those are about 50% of the total standard that we need to meet.
Okay, very good, Namir. So huge changes over the last 20 plus years. What about on the exhaust side, Lorenzo? Can you comment on the exhaust side?
Also on exhaust side, we had many different regulations. We have in each region different, and an evolution of the regulations every year. Now, also for the future, we have big challenges in front of us now. So every time we have to define new solutions to meet the emission requirement, but also to meet the acoustic, the homologative requirement that are becoming more and more severe. So this is the main, and for sure the list of regulations is long and different per each region. This is, in my opinion, the big challenge that we have in front of us.
Yeah, very good, Lorenzo. So clearly, Stellantis meeting our regulatory requirements is our number one priority, and you guys play a huge part in that. On the exhaust side, though, I'm curious, with the air coming out of the exhaust, how clean is it? And can you describe a little bit of how that works? Which technology in the exhaust system really addresses that? You mentioned some high temperatures before that are needed, right? Why are they needed? What do they go into and what happens? Can you describe that a little bit?
But we have two big families of subcomponents into the catalyst and diesel after treatment systems. One is to clean the air from AC, NOx, CO. Another family, filters, pure filters, to clean the air from the particulate matter. No, that is another big problem we have, in particular in our big cities. No, I can tell you that when you are in a very in cities very big with big traffic, huge traffic, I can say that now with the new regulation, the exhaust gases could be also cleaner than the air that is coming from the filter.
Wow, that's pretty fascinating. Okay, Namir, you also mentioned clearly these ever-changing and more challenging EVAP emissions requirements, and you mentioned ORVR and the vapor recovery during fueling. Any comments on, with respect to your system in keeping the environment, the air clean? How clean is it? You mentioned one contribution. Are there any other contribution from fuels that you want to comment on?
Yeah, so Marijana, you hit on it. As I would say, the ORVR, in addition to the vehicle level shed emissions. So, back prior to ORVR, as we refilled the vehicle, all of the vapors, 100%, are escaped to the atmosphere. With ORVR, we allow only 0.2 grams per gallon dispensed to vent to atmosphere. So that's huge. And I'll put this in perspective for you. As you remove the nozzle from your car to hang it on the dispenser, there's one or two, and probably more than one drop, several drops, right? When you make that transfer from your car to the dispensing pump, each drop of fuel is equivalent to roughly 40 milligrams of hydrocarbons compared to amount that we're allowed to emit during dispensing, which is 0.2 grams per gallon. So that gives you an appreciation. Even though the requirements are very strict, you basically blow what you're protecting by transferring the nozzle from the car to hang it on the dispenser, with a few drops, just to give you an indication.
That's really fascinating. I think to conclude on the regulatory and emissions, all I can say is thank you both for doing what you do with the systems that you do to keep the air clean, in some instances even cleaner than we found it. So really appreciate what you do for Stellantis. Now, to continue with a little bit more fun, I am totally notorious for not filling up until that light shows up. And I've been known, Namir, to call you a couple of times and say, how big is this tank and how much do I really have, as I'm calculating, right, how long before I run out of gas. I'm hoping that it doesn't happen. It has not happened yet. But in reality, what's the ideal when we talk about refueling, other than that personal preference? Where some people just drive until they're on E and they absolutely, like me, will not refuel before. Is there a sweet spot for the efficiency of your vehicle that you should keep your tank at or fuel at? What would your comments be? Is there an optimal level where you would refuel?
Yeah, and for the record, Mariana, I think you've called me about 6 times. No, I'm just kidding.
Let's not share.
Every time you get in a new car. No, I'm just kidding. No, but in all seriousness, the first indication of low fuel warning typically is 30 to 50 miles distance to empty. At the empty datum, the system is designed for minimum 20 miles range. We don't want to go any more than that, but we allow for 20 miles. In reality, not a lot of buffer, I would say, as has been done in the past, right? We want to allow the customer to travel longer than having to make frequent stops. We had more buffer, I would say, in the past. Not the case so much. I would say in terms of best practice, ideal, because a lot of people don't know this. Fuel is actually used to keep the pump cool as well. The longer you run it, I'll say at low fuel warning, or even longer than that, when your distance to empty goes to low fuel warning, you could potentially start to create some long-term damage to your fuel pump, because the fuel is actually used to cool the pump itself. And then if you really push it, you could potentially run lean, cause some subsequent damage to your system long-term. For example, my friend and colleague Lorenzo's catalyst system, you could be running lean, you could trip check engine lights, and potentially do some damage to the catalytic converter. So in terms of best practice, I would say no. I would say probably around the first low fuel warning indicator, but absolutely no later than when your distance to empty goes no show and low fuel warning.
Okay, very good. I'll keep that in mind, Namir. Thanks. Lorenzo, how about on your side, talking about these ideal refueling times? On the exhaust side, are there any recommendations that you would have for customers to keep the exhaust system working as efficiently as possible?
I think Namir has perfectly explained what is required. So I would say no additional comment on this point.
Okay. What about diesel systems like DPFs to keep them at the optimal level? How should customers use that?
For DPF, yes. In the past, maybe some of you heard some claims because the DPF was very far from the engine. This was many years ago. And what was the problem? The problem was the temperatures of the exhaust gases that were not enough high to have an efficient regeneration. When of the DPF, that is a filter, so sometimes you have to clean the DPF through the combustion engine. Then in the following years, we have worked in order to move to change the position of the DPF that is now very close to the turbocharger. But in any case, the suggestion to the customer is always sometimes to go to the highway and do some accelerations, let me say, high speed, not always in urban driving conditions, because it's not the ideal way to drive a diesel car. No?
Yeah, or we just recommend buy our large trucks, buy a boat, and just haul it behind, yes?
Yeah.
Okay, very good. Very good. Okay, so given these extensive backgrounds that you guys have shared, and clearly a lot has changed, both of you have shared in the industry over the years, what do you think the most dramatic changes with your systems are that you haven't mentioned yet? Maybe can you think of anything, or did we cover it pretty good?
Yeah, for me, Marijana, since starting in this commodity with my first role, a lot of controls, sensors, evaporative emission sensors, fuel tank pressure sensors for OBD diagnostics, liquid pressure sensors, and fuel pump controllers for PWM systems. When I first started, we had no PWM systems, and now they're more the norm than the exception, I would say. So electronics and electrical integration, I would say, for improved fuel efficiency, durability, NVH, and reliability. A lot of changes.
Very good. Thanks, Namir. Lorenzo, what about in your systems?
Something similar also on exhaust system, because we have now many sensors. So it's very important to work with our calibration colleagues, control colleagues, in order to during the development of the vehicle, because again, it's now very complicated, the development of the vehicle, not only the exhaust system. So there are many potential problems that have to be detected during the development.
Very good. Very good. Okay, so as we start to close this podcast out, what advice would you give to anyone listening that may be curious about propulsion and want to pursue their career in this area, or especially in your fields, fuels and exhaust? What advice do you have? Lorenzo, why don't you go first?
In my opinion, the recommendation, okay, if you have the passion for cars, as I have and as I had also when I was a child, this is for sure a very good starting point. Then for sure it's better to study, I don't know, to study to have mechanical engineer degree. I think that this to be graduated in mechanical engineer or electronic, it depends on the area, no? But for sure working in our department, I think it's better to be graduated in as mechanical engineers. Then I would say Stellantis is a big family, and I think is the right place to work. And if you have the passion, I think you have already done the majority of your job.
Very good. Thank you, Lorenzo. Namir?
Yeah, so for me, the advice I would give, the design release engineering role for a new engineer in any industry, frankly speaking, is so critical to building that foundation. A lot of people want to do vehicle integration, maybe NVH, but in my opinion, the best starting point, and I'm not selling, this is just fact, because I started as a design release engineer. When you establish that foundation, everything else will fall in place. So when you understand the releasing process, how to release a part, how the parts go into the car, how they integrate and interface with other organizations, you probably have done 80% of what you're going to be able to learn in this organization.
Great. Well, team, I have truly enjoyed our conversation. Thank you so much for your time. And thank you to our listeners for tuning into the Stellantis Tech and AI podcast, where we speak with some of the brightest minds, just like we did today, in the tech and automotive industries. We invite you to follow Stellantis Tech and AI on LinkedIn and Instagram to join the conversation, stay updated on what's ahead, and be a part of community exploring the fast line of tech and AI in the world.